I am recording this again, so just be aware of that. So today I did expect everybody, or I want you to watch, there's 2 lecture videos under the supermarket systems, and there's two under the ice makers and food preservation. These lectures are not long, okay? The lecture videos are relatively short. It doesn't make a ton of sense for us to spend our time with me showing you PowerPoints when we're here in the meetings. It just doesn't make a ton of sense. I would rather spend the time on some of the things going around the PowerPoints and also the schematics. I have a discussion board post out there. It's on ice machines. Please spend some time in the discussion boards. You guys have to answer my question and then add something to the two other students' posts. There's no right or wrong answers in these discussion boards. They're more aimed to get you guys to a little bit think about when you're in the field, how you're going to handle things and what you're going to look for. And it is based on the lecture videos, so, and a little bit of common sense. Fourth, make sure you signed into the design term, okay? There is a link, there was a self-enrollment link in an earlier discussion or in another announcement here on the course. Make sure you sign in there. I'm working on the book issue. I know some of you or most of you do not have the construction blueprint book. From what I have been told, you can go back through the order link in Canvas. You know, down here, I'm assuming you guys can see my screen. Down here in school links, if you go to the ebook and app code orders, you're going to be asked to put in your name and information.
Chris, we cannot see the screen.
Can you see the screen or no?
No.
Okay, thank you. I will solve that real fast. I thought I already did that. Sorry. Better?
Yeah, now.
Okay. So if you go under down here at the bottom of the left-hand side of the menu, the one with the pictures on Canvas, you can go to eBooks and app code orders. When you get there, you're going to be asked to put in your student ID number, your email, your school email address has to match, and your first and last names. Then you're going to be taken to a screen that basically has the information there for you to review. Yours is obviously going to look a little different than mine. And you're going to be asked to click on the ebook order system. Okay? Once you do that, you're going to be taken to a screen that shows you all your information again, and you'll just click Submit ID. Okay, once you go through that, you're going to have one more prompt just to make sure you want to order the books. Please go ahead and order. Go into your Vital Source bookshelf and update the bookshelf. Okay, and you should
Chris
get
is here.
new books.
Chris, what is our the student ID supposed to be?
Okay, on your ID badges are a little bit different than mine. Is there a 6 or 7 digit number someplace on your ID badge?
Let me look.
It's going to end in the same 3 numbers that your email address ends in.
Oh, okay, I see that.
Okay, can you tell everybody where to find it? Because again, your badges look different than mine do.
It's just right under your name on your badge. It says student, and then there's like a 9 or 10 digit code.
Okay, yeah, it ends in the 3 digits that is on your email address.
Okay.
Okay,
like,
that's
what are we doing with that?
You'll put that on the first screen that you get to. Let me back off here. On this screen, once you click on the link to get to the ebook, remember this link right here, the ebook and app code orders, you'll get to this screen. You're going to enter your ID number, your school email address, your first and last names. You're going to click Submit.
I can't see any of the screens. It's just like black with the loading sign on it.
Yeah, apps.
Can other people see my screen?
I can.
Yeah.
Okay. Who was that said they couldn't see it?
Me, Yuri Fernandez.
Okay, go into Canvas. Let me see if I can describe this. Go into Canvas, or if you're not in there already, on the left menu, it's sort of a blue menu with some icons.
Yep.
Scroll all the way down to School Links.
I'm in the app, and I don't School Links. Okay, yeah.
Click on that.
Yep.
And you should have a choice for ebooks and app code orders.
Yep.
Click on that.
Got it.
Okay, you're going to be asked to enter your ID number, your email address, and your first and last name.
Okay.
Then once you do that, you're going to click Submit ID, and you're going to be taken to another screen that gives you a choice of either app codes or ebooks.
Okay.
I need you to click the ebook.
Oh, the ID number is the whole 10 digit. Let me find it.
Chris, I just typed all my stuff in, and it says that it didn't match up.
Okay, if anybody doesn't match or gets a message that it didn't match up, could you just send me an email and tell me what you entered for your student ID number, and just put in the email that it didn't match. I'll check that after this class, get back to you.
Okay, thank you.
I know I came in late, but how do we get to this section this page right here that you're on to log in?
Okay, click on if you're in Canvas or in the app. Okay, I don't know exactly where it is in the app, but you have a choice for School Links.
Ooh.
It might be in if you're in through the browser, it's going to be on the left-hand side of Canvas when you're in the course, all the way down near the bottom.
Yeah.
If you're in the app, I'm not sure exactly where it is. Maybe someone can tell me. Okay, once you find School Links, click on ebook and app code orders.
Bro.
Okay. And again, if you can't get in because your information doesn't match or something like that, just send me an email. Give me what you entered as a student ID number, and I will fix it sometime after this call, okay? I'll get to it as soon as I can. Okay. So that's sort of important, and starting tomorrow, we will be in the 1416 course. So again, if you have not signed into that course yet, please sign into that course, okay? There's a self-enrollment link in one of my other announcement messages. The other thing I wanted to make sure you guys saw was down at the bottom of both of the refrigeration courses, there's a module called Instructor Notes. I've never made these available to students before, but because of the fact that the situation we're in, and I'm a little bit concerned you guys may not have all the notes you need, I've made these available in these two courses. Please think about downloading those. Okay. Okay. Can you guys still hear me? Someone's posted in there that they can't hear me.
Yeah, we can hear you.
Okay. Someone posted in the chat they can't hear me, so I just want to make sure. Okay. So again, the instructor notes are in the bottom of both the refrigeration courses. Guys, these are outline of notes we used to use before we had the recorded lectures, before we had PowerPoints and stuff like that. But I can tell you there's a ton of good information in there. I would suggest you go ahead and grab those if you can. They're not PDF format. You may have to just save the pages or copy the text. It's just, there's really good stuff in there. So take a look at that. I will post the wiring diagram, the wired ones, after everybody has submitted their schematics for grades. You guys can't just take the diagrams that I do, take a screen print of them and upload them. That's just not right. Doesn't tell me that you know how to do them. Okay, so that's what's on today's schedule. So any questions on any of what I've put in this course announcement? Okay. And where the section for the self-enrollment is, it's in the next course announcement. Okay, there's an enrollment link there. I need you to use that. If you're not enrolled in the next course tomorrow morning, I got to go to the registrar, and basically, they're going to have to reach out to you. So please, let's everybody please enroll in that course. And if you know somebody who's not attending this morning's call, please tell them the same thing. Okay, so let's talk about schematics. For those of you who are not able to see my screen for some reason, you might have to restart the app because I know people can see my screen. But I want to talk about schematics. We're going to start with the schematic, the 14. And we're going to talk a little bit about these. So let me enter full screen on this one. And I'll take this up in size a little bit. Okay. So this again is what type of timer is this?
Accumulator.
What was that? What type of timer? What type of defrost timer is it?
Continuous run.
Okay,
or
okay,
defrost.
But yeah, you were right. It is continuous time run. But what I want you to do is recognize when you see this picture, it's domestic. Okay, so it's a domestic defrost timer. Doesn't allow us to change time settings on it. In other words, how often it goes into defrost. But it's a domestic defrost timer. Okay, who can tell me what a mullion heater, a style heater, and a style heater is? Anybody?
Those are just the door heater.
This is what you pay.
Yeah, it's around the doors, okay? So basically what it's doing is it's constantly keeping the frames, the edges of where the doors close, slightly warm so it doesn't build up condensation or frost if it's on the freezer. So the mullion heater and style heater are designed specifically for not building up frost and condensation on the outside. Okay, what about the drain heater? Where would that be located? Usually it's in the back of the freezer compartment, where when we defrost the evaporator coil, which is in the freezer compartment, the water that runs off the coil has to make it out of the drain without freezing. So we provide a little bit of warmth to that drain.
I still can see the screens. I'm sorry. It's just black with the loading sign in the middle, but I'm not able to see anything. And I've leave and restart the app like 3 times now, and it's not letting me do anything. Like, it's not showing me anything in the screen.
Okay. Are other people able to see my screen?
Yes. Yeah.
Yeah, I can see it.
Okay. Yuri, are you on the app or are you on a web login?
On the app. On the conference app, the conference call app, yeah.
I don't know what to do to solve this. Let me see if I can. Yeah, see, I'm only showing. Yuri, do me a favor. You're on your iPad, right?
Yes.
Can you restart your iPad for me, please?
Okay, I'll do it.
Okay, and again, I am recording this, so we can definitely get you caught up, and I'll work with you on this.
Okay.
So just let's restart the app.
Okay.
Or the whole iPad.
Okay, I'll do it.
Okay, thank you. And I'll get you caught up if we need to, okay? Oh, he didn't hear me because he's gone. Okay. So what type of power supply is this? What's our voltages here?
120.
That's correct. Okay. So are there any devices in here that are going to be powered all the time?
The light switch to the light.
No, the defrost timer.
Yes.
Okay, the defrost timer definitely is powered all the time because it's continuous. Yes, we're going to send power to the light switch and then the light bulb after the switch. The mullion heater. Those are powered all the time. Those are the ones I was trying to get to. Okay, so the mullion heater and the style heater, they're actually in parallel. Okay, so we want to power these things at all time, and then we're going to just I'm going to go ahead and, they sure messed this one up. So we're actually going to switch our neutral. Doesn't really matter, but in this case, for neatness, we're going to come down here. Okay, and I'm going to use my neutral. There. Let me just change colors there. We're going to power my mullion heater. Okay, and I'm going to power pin 1. We're basically going to power pin 1 of my defrost clock, right? Because that's what we're going to do for continuous run. Just sneak that wire in there someplace. Okay, is there anything else? Well, we'll throw that thermostat, of course, in there, so let's just take care of that. Is there anything else that is going to be a constant power on that side of the circuit, my blue side of the circuit?
Drain heater?
Yeah, drain heater I definitely want to take care of. Now, some refrigerators, just so you know, some refrigerators do cycle the drain heater with the defrost. Okay, so just know that some refrigerators cycle that drain heater on and off with the defrost heater. You could definitely power the drain heater. I am going to use it along with the defrost heater, but you are right, it could be powered all the time, but I'm going to do that. Anything else that probably should receive constant power? Again, we're talking domestic defrost. Okay, you're right, there really isn't anything else. So let's fix the other side of the circuit. Okay, I'm just going to bring this around to give myself a place to connect the commons into. Now, why doesn't it matter that I'm switching neutral? Why doesn't it really matter in this case? Real simple answer to that, because I'm required to have two sides of a circuit. Okay, anytime I break the path, it's going to do the same thing. Okay, I'm going to tie in my neutral on my evaporator fans. I'm going to tie in the neutral on my compressor, or the line on my compressor and there as well. Now, what type of compressor motor is this? Anybody?
A domestic hermetic seal compressor.
I'm more looking for type of start components. So we know we have shaded pole, we know we have PSC, we know we have, what type of compressor is this? I have two capacitors, right?
Right.
So it would be a CSCR, capacitor start, capacitor run.
Okay.
Okay. I have a start component with terminals 1, 2, and 5. Some of you guys, I know I went over this when I was in York back whenever. What type of relay is this?
It's potential.
It is a potential relay. On the motor, which is my start winding, the 3 or the 11?
11. The 11.
That is correct. So, what wires to pin 1?
Start capacitor.
Start capacitor goes to pin 1. Where does pin 2 go?
To 11.
To the start winding, which is the winding with the higher resistance. Where does pin 5 go?
To the run winding.
The common. You see this little
other capacitor
relay
goes to
coil
3.
in there? That picks up the back EMF. That's the generated voltage by that start winding. Okay, so again, whenever we have a pin 1, 2, and 5, pin 2 connects to the start winding, pin 1 gets the start capacitor, pin 5 goes to common. Where does that run winding connect to?
To the other capacitor that's above the other one.
Nope, nothing. Well, you could put it there, but it's only on the voltage feed side of that. We never put a capacitor before the run winding.
Yeah.
Okay, how about if we came up to the output of the thermostat? Actually, let's do that backwards. Okay, I'm going to go there. and then I'm going to...
You connected to terminal 4 on the defrost timer, right, from the thermostat?
Yes.
Okay.
So you're going like that. Let me not forget to connect the other side of this capacitor. And again, this gets a little nasty down here. Do that. Guys, that's not a connection right there. Where those two lines cross, they're not connected. Okay, evaporator fan, where's that going to go?
Right after the thermostat in 4.
Yeah, evaporator fan, we're also cycling off the thermostat. What about my condenser fan? Same thing, right? And I'm gonna move one wire there just to make it easier for a connection standpoint. Condenser fan. We're gonna basically I'm gonna cycle off the thermostat. Big junction point right there. Now, which of these windings on the bottom here, which of these windings is my start winding?
6.
The 6, the larger one. Okay, so obviously run winding gets pure power. Okay, what do we do with our defrost stuff? Our defrost components, where do they get wired in? Okay, our defrost heater and our defrost components get wired into my number 2 terminal of my clock. Now, I'm going to change wire colors here just to make it easier to see. Okay, I don't mean anything by it. It's just easier to see. So my defrost heater and everything get wired into the drain heater and the defrost. Again, some refrigerators do power that drain heater all the time. In this case, it was just easier wiring-wise to power it with defrost. Will this system work the way it's wired?
No.
Why?
The light switch.
You don't have power on the defrost timer yet.
Or the light switch.
Both are good answers. We're missing our other side of the circuit here for the light switch or the light. Okay, and I'll make that red just so it matches. And I'm also missing that wire, right? And let me pull this over and make a connection so I showed those there. Now will the circuit work?
Yeah.
Okay, so that light switch is your door switch, okay? That's that little push button or flip switch or whatever's on the refrigerators these days with the doors. So that is the working circuit. Questions on it?
So the capacitor with the little dot on it, those are always run capacitors?
Yeah, but start a little bit. Be aware that the dots are slowly vanishing on capacitors when you're looking at schematics in the field. They don't show the dots anymore. They've got it cheap, saving some ink or something like that. So just look for capacitors if they have a switching device after them. Okay, in other words, you have a switching device here, it's the start capacitor. If it goes directly to the start winding without any switching, it's going to be your run capacitor. In our diagrams, we put the dots on them, but the dots are vanishing when you're in the field. You're not going to see them anymore. Make sense?
Yeah.
Okay, so yeah, if it's a capacitor in series with the start winding and doesn't have a switching device, it has to be a run winding. What type of motor is this condenser fan motor? Anybody?
It's a start capacitor, run capacitor.
Run capacitor, but what type of motor configuration?
PSC.
PSC, that's correct. Capacitors always in the circuit. We're always giving our start winding some power, but it is slightly out of phase from the run winding because of this capacitor. What type of motor is the evaporator fan?
Would it be shaded pole?
It is a shaded pole. No capacitor, single winding, shaded pole. As is the defrost timer motor. Okay? If you want to take a quick picture of the schematic, go ahead before I go to the next one, which will be 14B. Okay, and again, don't just turn in my pictures for your own work. I do look.
I got a quick question on this schematic.
Yeah.
The left side of the thermostat, is that also connected into
No,
the...
it's a close call, okay? It's so close.
Okay, that's what I thought.
It's just going to 4.
Gotcha, thank you.
Okay, I'm sorry. That's why I moved that line over. I probably should have done this. Sorry about that. Okay. Okay, if there's no objections, I'm going to move on to 14B. Okay, 14B, we change it a little bit. It's still a domestic defrost timer, but we're changing to cumulative run. Okay? So now the defrost timer is only getting powered when the thermostat. We do not have the mullion heater. Well, we do down here. They've moved it. It's down there now. So what I'm going to do again, just to make this easy, okay, I'm going to just take my neutral all the way around. Okay. At least here they let me use the neutral to go all the way around. Now, is there anything on here that is powered continuously?
That's it, mullion heater and step heater again.
Yeah, and there's one more item.
The light switch.
Yeah, I can't forget about the light switch. People get upset when their fridge lights don't work. So we're going to go ahead and toss that in before we forget. And then I'll toss in the blue. I'll make that a red line real quick. Okay, I'll come down here to the mullion heater. Let me get the stuff out of the way that doesn't require switching. Okay, and I'm going to toss in the neutral sides of all these fan motors. Okay. Actually, that's blue. Okay. So now we're at this point. So where am I going to wire my defrost timer from?
Thermostat.
That's correct. So we're basically going to give our line power to the thermostat. From the thermostat, I'm going to come out to pin 1. I'm not going to forget the neutral for my defrost timer this time. So I'm going to go ahead and put that in there. Now, coming out of pin 2, let's take care of this first. Where is pin 2 going to go to?
Line on the relay.
Pin 2, it's my normally opened.
It's going to go to your defrost heater.
That's correct.
Oh, yeah.
Okay, so let's get pin 2 to the defrost heater. The green is just doesn't mean anything different. It's just I wanted to show that that's not a connection. Okay. Pin 4. What am I powering from pin 4?
Your compressor motor and your condenser fan.
Basically everything else, right?
Right.
So let's get that in down there because that's my easiest. Let's get my condenser fan in here. They make it easy. It's just a shaded pole. Okay. The S terminal, where does it go?
So at 33. Your 3. Start windings.
Start winding. Yep. M terminal goes to my run winding. You can always remember it like main.
What?
Okay. And then my L terminal gets my line. L for line. Okay. Now, what type of motor is this? The compressor. What type of motor is a compressor? I have 2 windings, and I do not have any start or run capacitors.
That would just be a normal split phase motor, right? A conduction
That's
start.
Correct. That's correct. What type of start relay is that? Current coil. Okay, it is the only time you are going to see a load in series with a run winding. Okay, that coil is a load, but the wire on that coil is so big, if you remember when I'm pretty sure I showed this to you guys in shop, or some of you in shop, the coil on that winding is so large, it's such a large wire, that it doesn't really have any resistance. It just energizes, creates a magnetic field based on current. When the motor first starts, there's some pretty heavy current in there. Okay, that will energize the magnetic field enough to close that normally open contact and energize the start winding. When the motor starts running, the current drops way down, and it's going to de-energize that relay, and the normally open contacts back to open. It's the only that you will have you'll have the winding in series with the run winding of a compressor motor. So just be aware of that. In terms of the overloads, these fail constantly on domestic refrigerators. Okay, they go bad very often. It is one of the most frequently replaced parts on domestic refrigerators. And a lot of times technicians do misdiagnose this. They tell the customer that their compressor's dead, and they end up spending a couple $1,000s on a new refrigerator. And the reality is, the overload is, I buy the part for about $1.25, charge someone $60 to put it in, because it's a pain in the butt to get to. So, but it is the most frequently misdiagnosed part in domestic refrigerators. Now, in some situations, you will find that this exact diagram in commercial equipment, okay? For those who've ever worked in a kitchen on the line, you see some of these domestic defrost timers in the small reach-ins that you do store your prep food in under the line, the little single door reach-ins. They sometimes have the domestic timers on them. They're cheap, they're easy to replace, and those refrigerators are normally emptied every night anyways. So just be aware, just because it says domestic, you might find this exact setup in other places. Now, one last question on this schematic that's pretty important. Why do we have the fan switch on the evaporator fan? And it's okay to guess.
You don't want to run it when the process is on.
Well,
or when the
go ahead. Who was the second comment?
I said when the door to the freezer, you wouldn't evaporator fan running.
Yeah, if I have the door open. The first answer was correct, but not for the fan switch. The first answer about not running the evaporator fan from defrost. Opening the circuit to number 4 when we go into defrost mode takes care of that. But the more important part is when I have this door open to a warm, moist, humid environment, like you would see in a commercial kitchen, okay, or maybe in a bar, okay, I don't want that evaporator fan running, pulling that moist air across the evaporator, because it's going to build up ice faster. Okay, so when we open the door, we shut the fan off. And you'll also see this a lot in the deep freezers that people have in their houses. Okay, the single door deep freeze, either the chest type freezer or the upright type freezer. You see this a lot. We shut off the evaporator fan when the door is open. It prevents ice buildup. Okay, any questions you guys have on this diagram? Okay, go ahead, and if you want to take a snapshot of it, take a snapshot of it. And then I'm going to go on to 14C. Okay, 14C. Again, we have continuous run domestic timer. Okay, I have that light switch again, the tons of heaters. We do change the start device. This is a Ptc Start Device. Okay, start relay. What this basically does is that high amperage at the startup starts to heat this up. This will get warm. As the temperature rises, physically rises, you can feel this get hot. The resistance also goes up. And eventually the resistance will get high enough that there's no power anymore going to the start winding. So it's a positive temperature coefficient start component. These come in 2-wire, which this is, but they also come in 5-wire that connect to all terminals of the compressor. Okay, these are replacement that is being used in the field. If you have a bad current coil relay, you replace it with the Ptc Start devices most often. And the reason is you can carry one Ptc Start device on your truck, and it will match a whole lot of compressors, different sizes, different horsepowers, and it will match all those different components. The current coil relays are very specific for the compressor. you actually have to match them to the specific amperages that compressor draws. But the PTC is slightly more forgiving. The larger PTCs that have the multiple wire also contain the overload right in the Ptc Start Device. So, having said that, let's go ahead and wire this one. Again, I'm gonna neutral around it. We're just gonna have okay. What gets powered constantly? Anybody? What gets powered constantly?
The mullion heater and the style heater.
Mullion heater and style heater get constant power. Okay, so I'm going to go ahead and tie my neutrals in first, and then we'll worry about the lines. What is the DTS that's on that defrost heater? What's it there for?
Take out a defrost if it gets too hot.
Yeah, it's something that's actually required by law. We have to take out the defrost with a temperature actuated, a high limit or something, if the system fails. In other words, if the defrost clock fails and leaves this in defrost like forever, I have to have a temperature limiting device in order to take out that defrost heater. So let me just go ahead and I'm going to wire in the neutral side of this. What motor's missing from this diagram?
Condenser fan.
Yeah, does anybody have an idea why the condenser fan's missing? That's not a mistake. Have you ever seen a refrige or a freezer that probably doesn't have, you might have one in your house that doesn't have a condenser fan motor?
Yeah, it's just got like the big condenser coil on the back.
That's exactly right. Or the newer ones have the condenser coil buried under the sides, right between the metal and right under the metal of the outside case. Okay, so if you feel the side of it when it's running, it's warm. Okay, that's where the condenser coil is, and of course we won't have a condenser fan motor. Okay, so we have a continuous run timer. Where does my power go? Does it go to the thermostat or to the timer?
The timer.
The timer. So we're going to come down to pin 1 of the timer. Put it there. Okay. Now, where does pin 3 go? Let's get that tied in since I'm just about as bad as everyone else forgetting to tie that in. Where does pin 3 go?
Take it back to neutral.
Take it back to neutral. Okay. So now our timer's operational. Let's tie in our line side of our mullion heater and style heater so we don't forget about those. They're getting power constantly, so we're just going to come across there. Some of the newer refriges and freezers, you will actually see a switch on before the mullion and the style heater. It's going to be called an energy efficiency switch. Some of the newer refriges, in order to meet energy code, like so they can say they're Energy Star compliant, they're actually giving the customer an option to turn off the mullion and style heaters. Not recommended, okay? But they give that option so they can say they're energy efficient. There would be a switch right there in the line between line and the mullion and style heaters. Okay. On to defrost. Where is my defrost and drain heater going to be wired to? Where am I going to take that from?
To number 4.
4's normally closed, so that's my normal operation. Where would...
I would say I would say 2.
Yeah, I'm going to go with 2 because that is my normally open. So when when it goes into defrost, my normally open would close and allow my defrost heaters to come on. Make sense?
Yeah.
Okay. Now we have one pin we have left to wire. Okay, and that's pin 4. Where's pin 4 going to go?
The thermostat.
To the thermostat, that's right. Okay, coming out of my thermostat.
Ptc Start.
I'm going to actually come straight down here, and then I'm going to connect the Ptc Start, going to come out of the Ptc into my start cap, and then where does my start cap connect?
Start windings
to 33.
This is my start winding, right? Okay, then that comes directly to line, coming out of the thermostat. Fan switch again. Got to cut that fan off if the freezer's open. Okay, does anybody have any questions regarding
Yes, you know what that is on Minecraft? Yeah, I think they showed it to me once.
Okay,
Yeah,
any questions on the diagram?
It's so strong. Yeah. It can kill animals. And then it has those green things come down to the floor.
So you're not letting me mute.
Grab a picture of it if you want.
And I need a map.
Okay, you can go ahead and grab a picture if you want. And then I'm going to go on to, let me pull it up real quick.
The body and the cheese for it. And people want to be a baller.
Okay. I want to do 2 more of these, and these are from a little bit earlier on in the course. I believe this one is labeled in your... this one, I think, in the course might be 1C. Did we go over this the other day? Anybody?
No.
Did we do this on Friday?
I believe so.
I think that we did this one too.
Yes, we
That
did.
one.
That's
Yeah,
when
I
Lathan
think
kept
that's
getting
one
stuck on that blue wire.
Yeah. Okay, what about this guy? This is probably 1D.
So no, I haven't seen that one yet.
Yeah, some of the guys in Brad's class.
Which one is that one?
This is 1D. Some of the guys in Brad's class may have seen this one. I might have done this with you guys when I was there in York. Not 100% sure, but let's go ahead and look at this. What type of defrost clock is this?
It's commercial.
It is a commercial. Okay, anytime we have a commercial, we can change. We have extra pins, and we can change the timing on it. So in other words, I can add and subtract pins, and I can make it go into defrost more often or not as often. This is a basic circuit that once those trainers are connected in the shop, which I have all the supplies waiting to show up there. Once the trainers are connected in the shop, this is one of the first schematics you guys will wire when you're working on those trainers. Okay, commercial defrost. What type of power is this one getting? What's the voltage it's getting?
240.
240.
Yeah, 240. Okay, L1, L2. Critical to remember, both of these are live. So even if you shut the thermostat off, okay, your devices, anything connected to L2 or L1 is still getting, okay? Enough power will take the tip of a screwdriver off. Don't ask me how I know. So we're going to go ahead and do that, okay? Just remember, when you're in the field working on this stuff, okay, as soon as you have a double pole breaker, you have to shut the breaker off when you reach in here to do something, because both of these are live. It's not like a neutral that's tied into the ground. Okay, I'm going to go ahead and connect my common sides in just so I have that done. Okay, and I'm going to not forget about my defrost clock. And let's not forget about our potential relay. Now I have a question for you. Your potential relay, which side of the overload does it wire on? Does it
side
wire
without
on
the dot.
What was that?
The side without the dot.
Does it wire on the motor side of the overload or the line side of the overload?
Oh, the line side.
The line side.
To the motor side.
You're going to see it both ways, but the way it should be is on the motor side. The reason is if you have a surge or something, if you have a power surge that opens this overload, we want this relay not to get an energy difference across that overload. Okay, so I want to take it out. I don't want this coil to be powered. Now, again, you're going to see it both ways, but the recommendation is to basically do this with it. Let me just make this neater for you guys. Pin 2, where does it go?
Two goes to your start winding.
Which is going to be which one?
The 9. The 9.
The 9, yes. Pin 1, where does it go?
To the capacitor?
Through the start.
Start capacitor, right? Okay, where does my run capacitor fit into this whole thing?
In the run?
It actually still goes to the start winding, but does not it's not switched, okay? So it doesn't go through the switching. It powers constantly. Okay, my condenser fan motor, where does this capacitor tie into?
Into number 5, the run winding.
Into the high winding with the higher resistance. In this case, it's 5. You're correct. Okay. Where does pin number 4 go?
Directly into the thermostat.
Into the thermostat, correct. Out of the thermostat, I am feeding all my other components.
Okay.
So I'm giving power there. I'm just gonna on the run winding just change a wire color. Again, doesn't mean anything except I don't want it to look like I'm making a connection here, okay? Run winding, always get constant power. Okay, we are talking commercial system. Now, what is missing in this system? I have a defrost clock. What don't you have in this system?
A defrost heater or a solenoid.
Yeah, I don't have a defrost heater or a hot gas solenoid. So what type of defrost is this?
Off-cycle.
Yeah, off-cycle defrost. Okay, so is my evaporator actually going to be switched based on the clock, or is it going to be powered constantly?
Constantly.
Yeah, it's going to be constant. Because I want this evaporator to run, okay, constantly, because we're going to shut the compressor off for defrost, but I still need the fans to run. Now, I am going to wire this in. Basically, I'm going to come over here and wire this into the line. Okay. And we're basically going to wire that defrost clock into line. So again, I have a continuous running evaporator fan. My compressor and condenser fan are going to shut off and defrost, but this is going to be what's called an off-cycle defrost. We turn our condenser and compressor off, stop cooling, and we defrost. Now, where you see these is in, we sort of call them medium temperature units, okay? It's the borderline between medium and low temperature. Our product is as close to freezing as we can get it. For example, I have a product at 32 degrees, which means my evaporator coil is running under freezing. Okay, so my box temp might be right above freezing. When this comes on, my evaporator is running under freezing, but I know my box temp is never going to be cold enough that I can't just turn it off and circulate air across it and defrost it. Does anybody have any questions on this? Okay, that is the diagram, okay? There's no defrost termination. There's no defrost heater. We're just using a defrost clock to shut off the condenser fan and the compressor. You guys can take a picture of this if you want. The ones I post are only black and white. The ones that they make for us are only black and white. Sometimes it's easier to have the color.
So if we had the defrost timer in this one, that and the solenoid, that's where the 3 and the X would bring those tied into the system, correct? The 3 pin and the X pin?
Yes, the 3 would be, I think one of our other diagrams that I'm going to go over has it, but the 3 would be controlling either my defrost heater, which obviously would have a high limit on it, or the defrost solenoid.
Okay.
Now, if I had a solenoid, okay, if I had a defrost solenoid, which is hot gas, would I want to be shutting off the compressor and the condenser fan?
I'm going to say no.
Yeah, because you're right. Because I need to have the compressor to give the hot gas. The only thing I would be shutting off would be my evaporator fans. As soon as you go to a powered defrost, we have to shut our evaporator fan off and defrost. Make sense?
Yeah.
Okay. Okay. I think this one, I think this is 1E. Here we take the same clock. Okay, we take the same clock idea. And now we're doing exactly what I just talked about with the other defrost. Okay, we're going from off cycle, but we're going to what most people consider the easiest and cheapest form of defrost in the commercial environment, which is an electric defrost heater. I have a tendency to disagree on that, but that's okay. They don't pay me to be an engineer, but I actually think hot gas is the easiest to deal with. But let's go ahead and I'm going to first put my neutral in. Okay, this is a case where I really want to make sure we use neutral for neutral. Okay, in L1 and L2, it doesn't matter which one I take around. In domestic, it really doesn't matter what I take around. But things get confusing in commercial defrost as soon as you have a defrost termination if you don't take the correct pins around. So we're going to do that. Okay, now I'm going to tie in my, make that straight there. I'm going to tie in my overload. I'm going to tie in my compressor motor. I'm going to tie in my condenser fan motor. Do I tie in my evaporator fans to neutral?
Yes.
Careful on that one because you have another device down here we got to be aware of. Okay, so do my evaporator fans go to neutral directly or do they interact with this DTS fan delay? Okay, what you're going to do in this case, okay, your fan delay is going to be your DTS, which is the defrost termination, is going to be my neutral. That gets neutral. Now, this is a single pole, double throw, or double pole, single throw switch, okay? So what we have here is when the temperature rises, the thermostat goes to its up position. It brings neutral back to the X terminal, which is my defrost termination. Okay, we're switching neutral because you take a look at the inside of the clock. This right here, right between the X and the number 3 terminal, is that solenoid. I don't know if you remember seeing it in the shop on the bench. We had that defrost clock, and if you picked it up and flipped it over, you had a solenoid in there that actually pushed the clock, physically pushed the thing out of defrost. So this is the DTS and fan delay. Okay, so when it's in its warm mode, in other words, defrost has run and taken all the ice off of it, okay, we're going to energize that solenoid. Now, the defrost fans or the evaporator fans do not come back on until the coil has cooled off. So in other words, our compressor and everything comes back on when we come out of defrost, but the coil is still warm. We don't want to turn the evaporator fans on until that coil is pre-chilled. So we're going to wire the coil, and again, I'm just going to use a different color here just to show that it comes straight down. Okay, we're wiring those fans together, and we're coming there. Okay, so my evaporator fans will not come back on until that coil temperature is dropped. Make sense?
Yeah.
Okay, so again, DTS is always on the neutral side. Now, let's go ahead and we have one more neutral I need to tie in. Okay, I cannot forget about my defrost heater, which also needs a path to neutral, and that's going to come out of my limit switch. Okay, my limit switch is going to be on neutral. Okay, what pin of my defrost clock feeds the defrost heater?
4.
Number 3.
Normally closed or normally open?
Normally open.
Yeah, 4 is normally
So
closed.
3. Right.
So we want to come out at 3. And I'm just going to use a red wire down to there.
Damn you, Jacob.
Okay. Coming out of 4, where am I going to come to?
Thermostat.
Thermostat, that is correct. But I also am going to come to one other place out of 4. Where?
The high-low pressure switch there. No?
That's going to come after the thermostat.
Oh.
Yeah, the line for the
line on the
current relay.
That switch there. Yeah.
How about my evaporator fans? Would that be an acceptable place?
Oh yeah.
Sure.
Remember, we don't want to feed our evaporator. I don't want to power my evaporator fans during defrost.
Right.
Okay. Now I'm going to come out of here to my combo pressure switch. I'm going to come out of my combo pressure switch. I'm going to go to my condenser fan. And where else am I going?
The L on the current relay.
L on the current relay. Yes. Okay. Out of S on the current relay, where am I going?
Through your start capacitor into your start winding.
Mm-hmm.
Okay. M on my current relay?
The run winding.
The run winding. Now I have one more wire I have to toss in or nothing's going to work. What is it?
Your line voltage.
Yeah, let's get this line down to
1 and 2.
That's a magnetic. That's a brass band. You see that little band connecting them? That's a copper band, so it really doesn't matter where you go on that.
Right, so you're connecting it right there in the middle.
Yeah. Any questions on this or sequence of operation? This is one of the most frequently seen circuits in commercial refrigeration. Okay, go ahead and grab a picture of it if you want. I'm going to go on to a slightly different version of this. I want to do one more and then we'll probably wrap it up. Not that one. Let's see if I can find a hot gas. There we go.
Hey Chris,
yeah.
What about the what are we supposed to do for the questions that require a picture on the homework?
If you started it before I deleted the question, just skip it and submit. Okay? I did go delete the question. I will fix any grades. A couple people emailed me yesterday on this. I will fix any grades for that one. I did go back and delete the question, but I suspect if you started it before I deleted the question, it still exists, but I will fix the grades.
So if I go back and just do the rest of the questions, then you'll fix the...
Absolutely. A couple of you guys emailed it to me on this. Thank you much for the email. I appreciate it. And I did delete the question. But again, I will watch the grades, and as soon as everyone has it submitted, I'll go fix the grades. Okay, what's different about this diagram? I think, and someone needs to correct me if I'm wrong, this is one of the 4s. This might be 4B.
You got the liquid line solenoid and the hot gas solenoids on there.
Yes, so what does the compressor do during defrost?
Should stay running.
Should stay running, that's correct.
Did anyone find this, though? It isn't 4B.
Hang on a sec.
It's 4A.
It's 4A, thank you. When I pull it up, the numbers don't exactly match. I'm sorry. But 4A, folks. Okay. So let me go ahead and start off by running I'm going to use L1 as the one that goes all the way around, basically. I'm going to use L1 as my common. It just makes it easier. Okay. We're going to tie in all of my commons. I'm also going to tie in my defrost termination thermostat. And we know my hot gas and my liquid line solenoid have to get a common. And I might as well bring that X terminal back to common. Okay, X on this clock is neutral. Again, watch your terminal designations because sometimes different manufacturers, even the same manufacturer, changes them around. Okay, what controls the liquid line solenoid?
Thermostat.
Yes, that thermostat controls the liquid line solenoid. Okay, so we are going to come out of 4. And actually, in this case, I have 2 normally closed on here, right? I have an N and a 4. So I could come out of either N or 4 and be powered for normal operation. And again, just for ease of operation, I'm going to choose N. So I'm going to come out of there. I'm going to come into my liquid line solenoid. Which pin feeds my hot gas solenoid?
Wouldn't it be 1?
It's 1, yes, my normally open. Let me change some wire colors here before I confuse everybody. So 1 is my normally open. That's going to be my defrost. Now, you see this unlabeled pin down here? Where does that come from? There's an unlabeled pin.
Doesn't that go to your
pressure switches? Yeah, that one. That's what I meant.
The top of the high side of the defrost termination thermostat.
There you go. Yeah.
Make sense, or you just agree?
No, yeah, I'm agreeing. I didn't know the name of it though.
Okay. Yeah, it's either labeled. It's going to be either labeled a defrost termination thermostat (DTT) or a DTFD (defrost termination fan delay). It could be labeled either way on diagrams. Okay, and that is neutral. And I need to fix the 2 lines I put in, or 1 line that I put in there that I shouldn't have. The bottom half of this goes to the evaporator fan. Okay? The bottom side of the defrost termination fan delay is my common on my evaporator fan. What type of capacitor is this?
It's a run capacitor.
Yeah, so what does it go in series with?
With the run winding?
Start winding.
Oh, start winding.
Again, we don't ever want to put a capacitor in series with the run winding. Now, you a lot of times see the other side of the capacitor is used as a junction point. Okay, it's going to junction. It will have like 2 or 3 wires on it that you're going to use it as a junction point. Doesn't mean it's in series with the run winding. But if I go there, and if I take my power feed, okay, I'm going to wire there. Okay, I'm just using that side of the capacitor as a junction point. Everybody follow?
Yeah.
Okay, and again, we're thinking in a unit. This is how it's going to show up. Now, Who can tell me what the fan cycle switch is for?
It's for the condenser fan.
Yeah, why do we want to cycle it on and off?
So it's not blowing out the cold? No, never mind. I think it's something else.
Yeah, you're thinking the evaporator.
Yeah. Because the compressor's still got to run for the hot gas.
Depends on the ambient air temperature.
Yeah, the ambient air, never said that. You're right on. Okay? Because on a cold day, if I run my condenser fan, I can actually drop the pressures low enough that I start building up ice. Okay, so my condenser fan, we cycle it on and off based on pressure. And by the way, it's on the high pressure side. Okay, I cycle it off based on pressure of the high pressure side, which tells me what the ambient air around the condenser is. So I'm going to come into my run capacitor. I'm going to use the left side of that as a junction point, and I'm going to put that in series with the start winding. Okay, now the compressor, where does 5 go?
To the start winding.
5 goes to...
No.
To common.
Damn it. Yes.
Goes to common. Where does 2 go?
2 goes to your start.
Goes to my start. Where does 1 go?
Goes to your start capacitor.
Goes to my start capacitor. Where does my start capacitor get wired to? Any place where I have line. And the run capacitor, again, we're going to put in series with the start point. And basically, I'm just going to bring it around.
This is just like the other one we did for that compressor.
Yeah, I mean, they're basically the same.
Yeah.
Make sense? Now, what do we have left to wire?
Run winding.
Just the thing.
This goes to L2.
I have a run winding, that's correct. So where am I going to bring that in?
The left side of the low pressure switch. Or high pressure switch.
Any place where there's a connection from the low pressure switch. Yeah, you're right. Where you're going to see it most often in the field wired, it's going to be a big ball of wire on one of these capacitors on the line side of it. Okay. Just like I used a connection up there, but it's going to be over here someplace. Okay, now I have one more thing I have to wire. My pressure switches. Where am I going to bring those pressure switches to?
L2?
Yeah, basically L2. Now, I could bring it back up here, but again, when you're looking at these in the field, where it's going to wire from most likely, this is why they put this big brass connection down here. Okay, it's going to wire to there. Okay, because that way you only have one bundle of wire coming from L1 and L2. Make sense? Okay, so again, this circuit, hot gas defrost, liquid line solenoid. With that fan cycling switch. This is, again, a very frequent circuit, and most often you see these in walk-in freezers. This is something you find in the walk-ins. Questions on this one? Okay. What did you think about those pictures that I threw in the discussion boards for today? Did anybody look at the discussion boards for today?
Yeah.
Okay, the ice machines. I threw some pictures in here. Okay, that is an ice machine.
That's crazy.
Okay, it's a centrifugal chiller. Okay, and it is tied to a cylinder-type ice machine. Okay, this thing makes 13 tons of ice every day. Okay, so this is our compressor. Okay, we have a receiver, we have an evaporator. Okay, it's all water and brine. Okay, these are the cooling towers. The second picture is the cooling towers that's associated with that compressor. That's out on the building's roof. Okay, they have 2 of them in here. Okay, sorry about the boxes. Best picture I could get, it was right after they had some severe problems. Okay, but it's basically, so they have 2 of these compressors in there, and what it does, it actually creates, their end product is pallets of the ice that you buy in the stores, the bags of ice. Okay, so 2 of them, they're creating 26 tons of ice a day. Okay, what I wanted you to do in this discussion board, and again, there's no right and wrong answers. Take a look at this system and what's the challenges of servicing this equipment. Okay, look how high that ceiling is and look at where these evaporator fans are. Okay, this is a challenging environment to work in because A, it's cold, B, this floor is very slick. Okay, there's ice building up on the floor. So there's some challenges here. Okay, and this ice manufactures in Tinton Falls, New Jersey. So it's sort of on the beach, and this was sort of in August. So just think about, as you answer this question, what are the challenges? And again, I'm not looking for a right or wrong answer. There's no single answer. I want you guys to think this through because this actually brings us a little bit into our design term, where we're going to start talking about the sizing of this equipment and what we have to worry about with the sizing of this equipment, as well as the sizing of air conditioning. Okay? Does anybody have any questions for me?
No, sir. Not from me.
Okay. We will be having our 9 a.m. again tomorrow. Same conference call, same place. For those of you who had problems seeing my video this morning, my video feed, please do me a favor and try to reboot your iPad before you log into the conference call. I forget who that was, Yuri. I'm not sure if that worked or whoever was saying it didn't work originally. I'm not sure if restarting worked. Other than that, you guys do have a few things you need to do. Discussion boards, get that homework in. I have to close out this course for the moment until we can get back to shop. I have to close this out at the end of the day. I'll probably won't finalize it till the morning. But just let's get everything in, okay? And other than that, you guys have a good day.
I got one question quick.
Sure.
The homework, the chapters 54, 55, that is the troubleshooting, correct? In modern refrigeration?
Let me glance at the book real quick. I think you are correct.
Okay.
And then,
let me just...
and then we have to, at my other job, we don't have to cover up. We're just on lockdown. No one in, no one out, unless there's essential personnel. So.
Yes, it's troubleshooting. It's the installing, servicing, and troubleshooting.
Okay, perfect.
Okay.
Awesome. Thank you.
Thank you much, folks. You have a great day. I appreciate your time.
You too, thanks.